you if there is any this is the heap. You allocate something here, and then you write something to here, and then you free this pointer, but the data is still in here. Yeah, this is the free operation, and this should not be used. But then you print this again. What if after the free? What if I polluted this memory with some malicious address, and this address is being used again later on? Then bad things happen. Yeah. So the vulnerability is that the freed memory should not be used anymore.
Can you remind that why the program can still access that memory after it's free? Shall it be any other instruction between some write different process and memory?
This is a read, because the content is still in here.
But if after it free the memory why the system just deny the memory usage of that kind of address, because this not belongs to this program.
Okay, this is a programmer's mistake.
Actually, how the system know that error address is in use?
How the system the program doesn't know that. The program doesn't know that because you specify these instructions, and it does what you specified. There's no mechanism to prevent such read or use for the free memory.
So what's the why do we need to?
Yeah, because this is the programmer's mistake.
What's the purpose of the free?
Of the purpose of free. OK，你 free 咗佢呢個 address 就可以俾其他嘅 component 用。
其他 component 係同一個 program 嘅。
但係就冇 erase 個 tag。
我知道。
咁我想問佢點樣知道？
它那塊區域是在 stack 裡面，就是說那塊區域永遠都是 readable 的。它 free 的原因就是結果就是說它有個 table 來 maintain 它 status， 然後就跟他說下次 allocate 的時候是可以用這塊區域，但這塊區域還是在那裡的，上面 memory 並沒有heap 並沒有被消除，所以我們還可以 accept 還有 read 這塊區域。它就有另外一個 data structure 來 maintain 它的狀態，就一下子malloc 就申請一塊就是動態dynamic 那個叫什麼 dynamic data 的時候，它還是可以 就是说只是把它这块重写掉了，它原来的数据还是在那里。
So, yeah, heap overflow. As you can see, this is a heap data structure. It's a little bit complicated. Let me see some. Yeah, why we need to use the, why there is memory management, it is used to avoid fragmentation, to improve the efficiency of memory space usage. And the metadata is also stored within the heap space. So if there is no, for stack overflow, if there is no check for the boundary, the return address may be overwritten. But for heap, the metadata may be overwritten. When the space is, for example, when this data is freed, there are some changes in this data structure. However, if we overflows the heap, the address, the content are overwritten, then how to say? Well, it's able to write what you provided it is able to write any data to any location because of the internal mechanism of free operation. For the internal working, there are several different kinds of limitations. You can check the details. Well, the high-level idea is that the metadata can be overwritten, and when there is free operation, the malicious code can, the attacker can write anything to anywhere. Okay. Yeah. So how to stop the buffer overflow? One way is to prevent execution of the stack so that the instruction pointer will not point to the stack. Yeah. You can see the instruction pointer points to text segment, and when there is buffer overflow, or when you provide shellcode onto the stack, it points to the stack, right? If we disable the execution of the stack, then it will not point to the instruction pointer will not point to the stack. Then we prevent this attack, right? Oh, sorry. And yeah, but we can still achieve the attack by return to libc, sorry, there is a C, which means you modify the return address so that it doesn't point to the stack, it points to the library function, which is executable, which can be executed, so that the library function will be executed, like system and execute those functions. Okay, and people came up with an idea, which is to hide the address of the desired library C code or the return address on the stack to randomize the address space, so that the attacker are not able to guess the address of the stack or the library function, the C library function. Right. But this is just a mitigation, it's not defense, because we can brute force search the memory space or use other vulnerabilities to leak the address of the stack or the C library. So yes, so we can still brute force this, and the defense is don't use library C code. Okay. Yeah, and then people come up with an idea called ROP, return-oriented programming, which is to return to the program itself. So, which is return to the program. Then how to execute the program. How to construct the functionality of the malicious payload is by collecting the gauges in the program. Yeah, we carefully design the gauges. When, for example, return address returns to here, it will execute this instruction, right? And then return to the stack. And then you return to the next gauges, which is at here, by using the stack. So the instruction is, the malicious payload is instruction 7, instruction 8, and then instruction 10, instruction 11, and then it will goes to instruction 18, instruction 19, instruction 20, and next goes to instruction 15. So the payload is collected in the original program. Do you understand the idea? Okay, you can check the details later on. Yeah, and the stack canary, or called stack cookie, which is put a random value before the return address. So the attacker have to guess the random value. If it's wrong, then exception handling will handle this, then this stack smashing will be detected if the random value is if the overwritten value is not equal to the random value. So before the return address, we add a random value like 5, 6, 7, 8, So you don't know the value, and you have to overwrite the return address. And before we returned, we check whether the content at here equals to 5678. For example, if you write A to this memory address, then A does not equal to 5678, then the program knows that there is a stack smashing.
It is checked by the program itself.
Yeah.
I think your stack is already, I mean the program is living in the stack. I mean if the stack is being broken, how the program can still check the value? They are just overflowing everything. And how is your program still able to?
Yeah, before every return, we check the value.
But isn't that the overflowing will overwrite everything up to the form of the array?
Yes.
And the instruction for the return function is before or after the array?
Before.
Before.
Before it returns, we check the value. This is implemented by the compiler. Just a piece of code, assembly code.
Is there a function generated for that piece of code, or they will
Oh.
just insert that piece of code in every time before the
Yes, this piece of code is inserted.
in every time?
Yeah, in every function return.
So it's a hard code. Hard
Yeah.
code